Hi, I'm going to show you how to capture a family of curves and save them one by one to a text file for later analysis with Excel or some other program. The saved points are just those points captured, not all the in-between ones filled in by the interpolate function, and therefore they represent exactly what has been measured. The family of curves will be for a bunch of capacitors from 1 nanofarad up to 11 nanofarads in amplitude range. Let's start with a 1.5 nanofarad capacitor. Anyway, that's how it's marked. So we go start sweep, and we capture this capacitor between 1 kilohertz and 1 megahertz, and it is indeed about 1.5 nanofarads, 1.56 to 1.493 nanofarads. Now, to save this, there are a number of ways. One of the simplest ways is to select the spectrum graph so that the Cleverscope control panel says spectrum, and then go File, Save as Text, and enter find a directory. Be a bit faster about this. I'm going to put them into a temporary directory, that one, and I'm call this FRA capacitors 1N5 and save that. Right, another way is to use autosave or fast save. These allow you to save each time you do something without typing in lots of names. So here you go File Options, here's File Options, and we're going to save using Fast Save button. We're going to save a text file. We're going to start with file 0 and end with file, well, let's say 100, and we'll locate and we'll go FRA caps, and now it will be saved with a name which starts with FRA caps, going FRA cap 0, 1, 2, 3, all the way up to 100. Okay. Now you'll see there's a fast save button up here, and if I click on it, it'll save it. So the first one's done, and it's FRA cap 0. Okay, I changed the cap to one marked 2N2, but before I do that, I'm just going to record that first run by using AddRef so that we've got it captured. We'll go start sweep. You can see the references captured, and we've got this new one, and it's reading 2N. Now it is marked 2N2, but I went and read it with another LCR meter, and it is in fact 2N. And now that we like that one, we go fast save, and perhaps we'd like to add that as a ref as well. And now we go to the next cap. Okay, I've plugged the next cap in. It's a 4.7 nanofarad. Now the last one and this one are disc caps, and the very first one was a mylar. So let's see how we go. This is also a bit low. It's 4.3 nanofarads, being a disc cap. So let's save that. Click Fast Save, and we'll add that one as a ref as well, and do the next one. Right, we've got the next one plugged in. It's a mylar, and it's marked 6.8 nanofarads. Let's try it. And it's measuring about 6.6 nanofarads. Now all of these are 20% caps, so I guess that's the reason. So we'll save that one, and we can add that as a ref as well. So now you can see that we can measure each one. We can go to other caps and measure them. So here we are measuring the 1.5 nanofarad. There we are, 2, and you can see each one in turn. Now we've recorded them, let's have a look at the contents. First of all, I open Excel. Here it is, and I've got the place I saved it to, FRA cap 0, 1, 2 and 3. If we drag that into there, we can see it. So the frequencies go from 1000 Hertz, which is 1 kilohertz, up to 1 megahertz. And you can see here is on channel A is the cap value, 1.5 or so nanofarads, and channel B is the ESR. And we can drag in another one, and we see that was the 2 nanofarads. And here's the 4.7, it's meant to be 4.7, but it's actually more like 4.3. And here's the last one, which was 6.67 nanofarads. You'll notice that the type is set as frequency FRA. We see the start and end frequencies. If I open that up, you can see the date and the trigger time. How many samples? 31 points. So there you have it. You can record these values using the FRA and then save them to a text file for later analysis in programs such as Excel or Matlab. Thanks for watching.